A conducting wire of length L lying normal to the magnetic field moves with a velocity v as shown in figure. Find the average magnetic force on a free electron of the wire. Right. Now first of all, what is happening is, let's say this is my rod. Now clearly there are protons and electrons inside this rod. Fine. So the rod is moving with a velocity v. There will be force on the electron as well as proton, and the force will be equal to qv cross b. So force on electron and proton is given by q into v cross b. So what happens is that electron will move downward, that is electron will be going downward, and the proton will be collected upward due to this force, right? So the average magnetic force that will be acting on a free electron of the wire will be given by q, that is the charge of the electron, into v into b. Fine. Then second case, I had to calculate, due to this magnetic force, electrons concentrated at one end. As I told you, electrons will concentrate at one end and they will result in electric field inside the wire. Of course, now what has happened is that protons are upside, electrons are downside, so of course there will be an electric field generated between them. The redistribution stops when the electric force on the free electron balances the magnetic force. Now clearly, if an electric field is generated among the rod, then the charges that are present at the center at this very time, they will experience a magnetic force as well as an electric force. Now we have to calculate the electric field developed inside when the redistribution stops, that is when the magnetic force is equal to the electric force. So electric force has to be equal to magnetic force. Magnetic force is given by qvb and electric force is given by qe. So E is cancelled from both sides. So the electric field developed will be equal to vb. That is the answer. And this third part, I had to calculate the potential difference that is developed between the ends of the wire. We know that the potential difference is given by E into D. So we know the electric field, so potential will be equal to BVL. This is my answer, and this is what we used to call the motional EMF. That is, when the rod is set into motion into magnetic field, then a motional EMF is generated across its end, and this is the magnitude of the motional EMF, BVL.